Good morning, everyone. My name is Kevin McMeans. It's a privilege to be here. Hope everybody's having a good start to the conference. As you heard, we're going to be talking about data centers and the impact of this on what's happening to all of us. And just to begin to frame it up, what was a niche sector for so many different years, and even from a couple years ago, has now turned into something that a lot of us are talking about and thinking about right now. So it's the scale that's happening, the speed that's happening is quite impressive. So again, my name is Kevin McMeans. I'm with Crow Holdings, based here in Dallas. We're a developer of a lot of different product types, data centers being one of them. It is my privilege to be joined by Bill Thomas. Bill is the Chief Energy Officer at CleanArc Data Centers, which is a development company that we are partnering with on a project that we have. And Bill's going to bring a lot to this conversation, and so what I would ask you to do, Bill, is one, welcome, and talk about yourself, what your background is and how it matters here.
Thanks, Kevin. Nice to be here. Thanks, everybody, for making the time today. Bill Thomas, Chief Energy Officer at CleanArc Data Centers. I'll talk a little bit about CleanArc first, and then I'll talk about myself a little bit. So CleanArc is a utility it's a greenfield developer of utility scale data centers. And utility scale really does mean utility scale. We build things in 300 megawatt tranches. We like to have campuses that are 500 to 1,000 acres. And we'll have buildings, 200 megawatt buildings. We'd like to have 3 to 5 of those per campus. So it is truly utility scale. My background, I'm a recovering scientist. I was a groundwater hydrologist coming out of graduate school. And the prospects for that kind of work when I graduated weren't great. It was working on Superfund cleanup sites and all sorts of nasty stuff. And so I did the next best logical thing, which go to Wall Street. I became an interest rate derivatives trader, moved from derivatives in financial markets to power, and started trading wholesale power for Public Service Company of Colorado, Xcel Energy, which eventually got me into the renewable development space. I worked at a big European developer, Eon Climate and Renewables, that's built a ton of wind here in Texas, a couple of gigawatts actually in Texas. First Solar, where I started their C&I business, and then RWE, which is another German utility that did a lot of development here in the US. Around mid-pandemic, I started working with our CEO, Jim Trout, who was kind of working on this idea of trying to merge these two worlds of digital infrastructure at scale and clean energy transition. And he thought that there was a reason for those two things to come together. And indeed, there was and there is. All of our customers are really the hyperscalers of the world. And the hyperscalers are, Meta, AWS, Microsoft, Google, and Oracle for the most part. So it's a pretty limited market, but pretty good names and pretty big credit. And so the idea there was to try and bring these two together, knowing that those hyperscalers had internal mandates, and they really, to mitigate their carbon footprints, and they did that by, sort of procuring a lot of renewable energy. So the idea was, we'll bring the digital infrastructure at scale, and we'll bring a bundled clean energy component to that offering, put them together, and meet the customers where they are.
Great. So as you can tell, you're the right person to be talking about this. One step before we get into the reliability side of the equation, or the source of the power production equation, let's just maybe frame the constraint, frame what's happening, frame what has changed, in this sector. Whereas, a couple years ago, seemed like we were kind of at equilibrium. We were bumping along at a reasonable growth rate. and then all of a sudden we've gone to, tremendous demand and the impact of that. So how would you frame that?
Yeah. So again, when we started our business plan we started late 21 working on this. Our initial prototype building was a 24 megawatt IT building. And that was, in our eyes, massive. That was going to be the hugest building that anybody had ever built. I mean, it wouldn't have been, but it was big. It was big for that time in 2021. By the time we got funded in February of 2022, the building was already 67 megawatts. And now the first one that we're going to build here in Northern Virginia will be a 135 megawatt building. So the scale of the business has just blown up. And it's not because, some developer said, we're going to just go big. It's because the market signal is really there. And the demand for the product is there. If you go back and you look at the combined 5 hyperscalers CapEx commitments in 2021, they had planned on spending something like $100 billion in CapEx for their data center infrastructure. 2026, the estimates are now $750 billion. So the market has absolutely blown up. And so that becomes a very real constraint for everyone, not least of which the utilities. Back when we started our program, for a 20 megawatt building, you could go to the utility and they could find 20 megawatts of headroom capacity, on any given circuit, right? That has completely changed. We are now in the utility business, whether you want to be or whether you don't want to be. You are in the utility business, and you know this well, Kevin, from your experience here. You need to be part of the utility's long-term transmission planning and generation planning. It's both things. Certainly here in Encore's service territory, it's not just a transmission issue, it's a generation issue too. And so the scale of the business has really transformed the way that the utilities are interfacing with developers. At the same time, it's become a gold rush, and now you have a ton of speculative activity. Kevin and I were just talking about, Kevin knows more about this stuff than I do. He just informed me that the queue in ERCOT has gone from 240 gigawatts to 400 and something gigawatts of large load demand. To put that in context, hottest day of the year in the summer in ERCOT is an 80 gigawatt peaking system. The entire ERCOT system is an 80 gigawatt peaking system. There are over 400 gigawatts of load studies from large load data centers that are trying to come online. It's moved into irrational.
And, following on that, Texas is probably unique in that regard. That said, utilities across the country have been and are experiencing this same level or similar level of demand and growth. And, if you go back, if you started a couple years ago and went back to the 10 years prior to that, our overall utility demand in the United States was relatively flat, maybe bumping up a point or two per year, but it was a rational level of growth. And so you really didn't have much of an issue or problem and not much, growth in demand. And then, what you then started seeing, around COVID, a little bit before, a little bit after, you did start to see real demand growth. Artificial intelligence, no doubt, is a big part of that sitting here today. But even before artificial intelligence, there was a lot of other things that started to drive, what was going on in the world of data centers. It was, think about, the Internet of Things and all the devices that we have connected to the one that's in our pocket, to all the connected apps and the connected devices into our houses. All of that goes through, a data center in some capacity. So you've got the Internet of Things, you got autonomous cars, you've got, medical robotics. There's just a lot of growth that has been happening. Now you supercharge that with artificial intelligence. And so it's a maybe a long-winded way to say the utilities were not set up for this level of demand. Frankly, nobody has been set up for this level of demand. And Bill referenced the CapEx spending from the top 4 or 5 hyperscale companies, again, those groups, has been astronomical. And just when you thought it wasn't going to go higher, then the update that they came in, early this year, took what was a growing line, sorry, I go your direction, a growing chart up to basically turn it to a vertical graph. So the demand is real. Good news is it is coming primarily from, some of the top technology, top credit-rated companies, top balance sheet companies in the United States. So it's real. Let's maybe move a little bit. We now talk about the source of the generation, and then you start to hear things like grid, on-grid, off-grid, behind the meter, co-location, and it can get a little bit complicated until you spend some time in it. But is there a way to think about that and where the power is coming from, the source of the power, and how we should think about that?
Yeah, I mean, there's definitely a change, and it's starting to propagate through the entire country. I mean, Senate Bill 6 here in Texas was one of the first ones to actually address this need for, large loads need to do something about bringing their own generation to basically insulate the rest of the ratepayers from these large loads that could disrupt the grid. And so there are certain provisions in Senate Bill 6 that require large loads to basically be able to cover their own loads. PJM is going through the same exercise right now. One of the weird things about the United States is that our grid system is not nationalized. It's not a federal grid system. It is very balkanized. The way that we do things in Texas is totally different than the way that they do things in the Pennsylvania, Jersey, Maryland market, which is totally different than the way they do it in California. Now, there are technical standards that are pretty consistent throughout, but administratively and regulatorily, they are very different. And so PJM is having the similar situation with this, bring your own generation, and that's being addressed in different ways. You might have seen that there was a federal kind of solicitation that went out for emergency power, and apparently somebody's going to build $82 billion a generation, and nobody knows who's going to do it or how it's going to get paid for or who's going to pay for it. But it's being driven by these large loads more than anything else, because to Kevin's point, he mentioned that load growth had been pretty accepted to be less than 1%, pretty much across the country. Public utilities commissions usually require utilities to write things called integrated resource plans, IRPs, every few years, and that number was really flat for forever. And it is not the case anymore. There is significant load growth here, and it's for the reasons that Kevin identified. I think like electric vehicles I think they account for only like 1/10 of data center demand. And that was a couple of years ago, so it's probably not even a tenth anymore.
Yeah.
So the trouble with bringing your own generation, there's several issues with it. The first one is that digital infrastructure hasn't ever had to do it before, right? So these are very smart people, and they're really good at building white space, and they're really good at operating digital infrastructure. Power plants are very bespoke, and they behave in a very particular way, and sometimes power plants don't behave as nicely as you would like them to with your digital infrastructure. There's a lot of problems that people have run into, and I think you see that here in Texas, where you've seen some of these behind-the-meter solutions that were, sort of rushed, and the result that the developers ended up with were pretty costly to try and fix some of the things that weren't engineered the right way a priori. And so I think as we go forward, you'll start to see more generation dedicated to digital infrastructure, but we're going to have to get a lot better about how we build these power plants and how we engineer them and design them.
And following that, again, the top technology companies, these hyperscalers, they have, and I think continue to prefer to be on the grid. They view it as stable. They view it as reliable, just with a lot of backups there. But because of the demand levels, the issues with bringing more generation and transmission online, they're going to be forced to move into this off behind the meter on-site co-located power generation.
It wouldn't be their preference.
Would be their preference.
Their preference is always to be grid connected.
Yep.
It's a much more durable system. Less or more points of failure, but like better diversity. Ideally, they would love to be grid connected. It's timing, right? And it's really that now, because of this 400 gigawatts that ERCOT has to study, the timelines for getting grid connected have moved out. I mean, when we started our work here in Texas, it was a 3, 6, 9-month process maybe to get to a facilities extension agreement that would kind of allow you to get your service. Now you're looking at, it's years.
Yeah. It was a year and a half. I can speak from experience. It's probably longer than that now. So I want to switch to two different places. One is I want to talk about, energy mix and how you think about that, especially with what you're doing, at Clean Arc. Well, let's start there. So as you think about, Texas has got one of the largest renewable generation in the country. Of course, Texas is a big state. But as you think about what you and Jim and your team are doing, how do you think about the renewable versus traditional, and how that folds into the reliability mix of these data centers, because the data centers do require reliability?
Yeah, I guess the way that I always start this conversation is to identify that this country has an electron problem. Not a green electron problem, not a brown electron problem, it's got an electron problem. Every electron is good. They're all good. And so when I think about how renewables can factor into our solution set, it's really from adding additional capacity. Now, I came from a renewable development background, and I was always stunned at how little attention was paid from the renewable development world to natural gas development, because the sun isn't always shining and the wind's not always blowing, and the reality is that those are intermittent resources. They're very good resources. They produce valuable electrons, but systems need to be balanced, and when the sun isn't shining and the wind isn't blowing, you need to be able to backfill it with something. And so I was always surprised that there wasn't more natural gas development coming online to work in concert with the renewable penetrations that we were trying to achieve. And I think it's good that we as a country and Texas as a state has done a great job of building out those renewable resources. But you need more balancing generation, and so we've always known that was going to be a problem, and now I think it's just been accelerated. Our renewable penetration here as a country is not particularly high relative to a lot of the other OECD countries. I mean, we're getting there. We're starting to get to a capacity where it's meaningful, but you need to bring renewables. You need to bring more gas. One guy's opinion, I don't think we need any more coal. That's open for debate if anybody wants to debate it. Not with me. But nuclear generation is going to be part of the solution set going forward. It's not going to be part of the solution set next year or in 3 years, but it will be part of the solution set. So, I think we need sort of a revisioning of the generation and transmission infrastructure in this country to be able to support these loads. And again, I believe it's an imperative for us. I believe that our ability to win the AI supremacy race depends on our ability to build that infrastructure and support the AI world.
Yeah, I agree with that point. That's another more lengthy conversation about, well, just from a national security perspective, you know, what this means, what it can mean, and what it can mean if we don't win this in step. Two things you said there that I'll repeat because I think it's important is one, the renewable and traditional working in concert with each other. It's not like you can have or should have just all of one and none of the other for a variety of different reasons. But again, in concert with a proper, you know, balance. And then two, nuclear. Here again, there probably is a discussion here somewhere about nuclear. There's some companies doing some interesting things, planning for either be it utility scale or more modular type of nuclear power generation, which will be interesting. Just it's going to be, you know, be some years out. What do you think about, you know, when you pull all this together, and you know, if you're, you know, maybe not as close to it as, you know, you and I are, you read the paper, you hear, okay, data centers are, you know, all this growth within the grid. By the way, a year or two ago, data centers were between 2% and 3% of the total grid demand in the United States. That's, again, depending upon which number you look at, is going to be 6 or 8% by 2030. Again, there's different prognostications and predictions there. But how do you think about whether it's, you know, the growth in demand, the renewable, the traditional, the behind the meter, the impact to the overall grid stability? Because one of the things we all think about, and for those in Texas that, you know, a few years ago got to experience Winter Storm Uri and what happened there, which was not caused by data centers when, you know, we had to go on rolling blackouts. It was caused by an unusual winter storm that, you know, the sun wasn't shining, the windmills were frozen solid, and then actually some gas generation plants had gotten some of their equipment frozen and went offline. But how do you think about, or how would you articulate just the ability for data centers and developers to impact the stability of the grid?
Yeah, it's interesting. I had an opportunity to write a proposal in conjunction with the U.S. Department of Energy and the Virginia Department of Energy, and it was to bring natural gas infrastructure to one of our data centers, basically to make that a more grid interactive resource. So we would have natural gas recip engines rather than diesel generators, so you'd be able to be much more interactive with the grid using those. And those respective DOEs went through a bunch of proposals, and we were like the only one that wasn't selected. And you know, okay, this was 2 years ago, but I think it's an interesting dynamic because I look at this space and it screams for having grid interactive resources behind the meter. And when we build our facilities, we build them with 100% redundancy behind the meter. So if we have a 300 megawatt load, we'll be grid connected for 300 megawatts, but we'll have 300 plus megawatts behind the meter that we can spin up to cover our load if we were to lose that grid connection. So you have a ton of capacity sitting behind the meters of these big facilities that's really just sitting there doing nothing, and it could be grid interactive. And I mean, if there's any regulators here, I'd really encourage you to think about that and to start to think about ways to utilize those resources, because they're there and they can be a great benefit in situations like Uri.
Yeah, that's a really important point because we lose sight of the fact that the generation, the backup generation that sits there is actually can be, part of the power source. Another way to say that is, and this was also coming out of Senate Bill 6 here in Texas, is this concept called load shedding, which is what you were just effectively talking about, which is, the utilities, the grid operators being able to say, hey, to any large loads who are pulling power from the grid in an emergency event, whatever might cause that emergency event, to say, hey, you, the large load, you need to shed, you need to stop using power from the grid. You can go to your backup, whatever generation you have on site. That allows that grid power then to go and support, all the retail customers, everybody else, the hospital, everything else that's on the grid. And so that's a really key point, and that came out of Senate Bill 6 here in Texas. It's happening in other places across the country, as well. So, okay, so now prognosticate. Let's look forward. Let's look forward to a few years. Pick your time frame. I don't have a real specific question, but as you begin to look forward and think about the sector, the space, the power, the generation, the stability of it, how do you, what's going to win? How's it going to win? How's it going to come out?
I think the answer is that we need to build a better mousetrap. There needs to be a lot more stakeholders participating in these large load initiatives. You can't do it in a bubble. You can't do it as an island, and that's historically how the space has been constructed. And so what do I mean when I say that? I mean, I think you need to start bringing in more renewable generation. I think you need to start bringing in more gas for balancing. A lot of that has to be behind the meter. I think you need to use more utility scale batteries. I think you need to create different partnerships that put the appropriate risks and returns on the appropriate stakeholders. Data center developers don't want to build, own, and operate power plants. We want people that are qualified to do that have been doing that for years. And I mean, we spend time now for our behind-the-meter projects where we're going to bring our own generation. We will partner with credentialed, pedigreed IPPs that are in the business of building power plants, know how to operate them, know how to finance them, know how to monetize them. It's just something that we don't want to do. So I think you're going to have to see more stakeholders and more partnerships to get these. These are really mega scale infrastructure projects, and if you want to develop mega scale infrastructure, you need a lot of players.
Yeah, my take on it is, and it's similar to what you just said, is there's going to be a lot of creative solutions. There's not one single solution to all this. It's not like you can just go build a lot of power plants in some place and run transmission lines to another place. I mean, in the end, that's what it's going to look like and potentially be built out. But I think that there's going to be, a lot of smart, creative people thinking creatively and thinking about different types of solutions, both on the supply and demand side. For the sector that Bill and I are spending all of our time in right now, we're talking about power right now, but the demand or the supply side of the equation across the entire spectrum is out of balance right now. Power is a big component of it. Power and transmission is a big component of it, but just the rest of the supply chain. There's a lot of equipment that goes into these data centers to make these things run and operate. Labor is a big concern right now. Labor right now, you've got when you see some of these projects being constructed, a lot of it is skilled trades that are working on these, and so you're seeing great demand. This has been a great benefit for this country and for a group of the population of this country. And there's people that are earning a really, really good income and salary and wage and creating wealth right now for themselves. Yeah, sometimes they've got to go all across the country to be able to do it, and whether it's Abilene or Lubbock or Dallas. But again, I do think that it's going to be some various creative solutions that address and solve this for us. We are out of time. It's been a pleasure to get a chance to speak to you all. Hope you all have a wonderful rest of the conference.
Thanks, everyone.
Yeah.